Well, good morning, everybody. This is the Saturday BVK Q&A. Everybody that's here, everybody that was invited to be here, had bought a body voltage kit. You've all got one. Comes in a case like this and includes the tester, E-pen, which we'll be going over all these parts, and then of course the meter itself to take the measurements. And this allows you to measure the electric fields in your space, but unlike a regular electric field meter, the body voltage kit is actually measuring the amount of electric field that's being induced into your body. So it's measuring the direct effect it's having on you, not just the space around you. And the thing about the spot meters is it's obviously measuring the field in that just one particular spot where the antenna is inside the meter. Whereas the body voltage kit is considering the whole body. So when you're laying in bed, you know, the field at your head may be stronger, but sometimes the field at your feet is stronger because there's something running underneath the foot of the bed. So this kind of averages it all out. And the way it works is the electric fields like to take the path of least resistance. So we plug in the ground cord, having tested the circuit first to make sure it's safe, and you've got two orange lights lit up. Tells you you've got a good ground to, and the positive and the negative aren't switched out, and everything's wired correctly. So we want to be safe doing that. Then we plug in the ground cord, and what we're doing is, because our bodies do act as an antenna, we're giving the electric field that I'm sitting in right now is about 250 millivolts, which is very low for daytime mitigation. And there's a reason for that, which I'll explain in a minute. So as the electric field I'm sitting in is dissipating from my body, following the path of least resistance through this wire, I get a reading. Now, I've got bare feet on the ground. So if I take my bare feet off the ground, the reading goes up to 320, which is actually a more accurate reading. And when I put my feet back on the ground, you can see it drops down. That's because part of the field is going through my feet to ground, but I'm on a carpet. I'm not on bare ground outside or a grounding mat. So take my feet off, and that's a more accurate reading. So this is actually one of the principles of using the body voltage kit that's really important. Don't be barefoot in your house when you're taking a body voltage reading. Of course, if you're laying in bed, it makes no difference because you're isolated from the ground by the bed. If you're in the kitchen or your office, bare feet on the ground is going to give you a false reading. So that's a very important point that needs to be remembered. And for those people who've just received the meter and this is their first exposure to it, and listening on to the audio later, the dial here, you turn it one click to where it says V, and then you can see over here on the screen you've got a little V sign. Then you push the red button once, and that takes it from DC to AC voltage, because we're measuring the AC fields in our homes coming out of the wires in the walls, the floors, the ceiling, out of all of the appliances that we have plugged in. And so that's the AC voltage reading, which for me sitting here with my computer plugged in charging, which I tell everybody, never use your computer plugged in charging. So how can I get away with 300 millivolts? And when I touch my iPad, oh, look, it's gone down. So I'm going to unplug my charging cord, and my body voltage goes up to 800. And when I touch the iPad, because it's my Ethernet that I have plugged in is not grounded. So this voltage, 3,000, just under 4,000 millivolts, is coming from my ungrounded Ethernet cord, which is why even though you are using a wired connection, it's really important you use a grounded wired connection. I'm doing this on purpose to show you why it's so important. But why, when I plug in my power cord, does everything go down? Because it is a grounded power cord, not the regular 2-pin adapter, but I'm using Apple's cord, grounding charger here, And everybody who has Apple is familiar with these little bricks, and you can unplug the grounded power cord, and you plug in the 2-pin plug. If I use the 2-pin plug when I touch my iPad, my body voltage would go up to 10,000. No, excuse me, it's 10,000 with the phone. If I use an ungrounded power cord, when I pick up the phone to answer it, my body voltage goes up 10,000 millivolts. My iPad goes up to 40,000 millivolts. If I don't use, this is the grounded connection, which Apple still sell. You have to get them on the website. They don't come with your iPads or your MacBooks anymore. You have to buy these separately. But because my system is now grounded by the grounding connection, the field is being significantly reduced and taken away. It's following the path of least resistance through the charging cord because it's a grounded connection, and it's keeping my body voltage low because I don't have that field radiating out of my iPad. So that's a perfect example of, even though I'm using an ungrounded Ethernet cord, which I'm using for our internet connection, so I can't unplug it. But I just wanted to show you what different, because if I unplug that and I wasn't plugged in to the grounding cord, so I was just using my iPad on battery, and this goes for any tablet, goes for any laptop. I said, when I touch the device to use it, which of course iPads and laptops, that's how you use them, my body voltage goes up to 40,000. So not only do you have the Wi-Fi and the Bluetooth to contend with, you now have the electric field to contend with, which is going through your body. So having a grounded system is really important. How do you know if it's grounded? You touch it. And if you've got a body voltage meter, when you touch it, if it's grounded, the body voltage reading goes down, because now some of the field that I'm sitting in, instead of going through the meter to ground, because the meter is offering resistance, it's now going through my other hand to ground, following the path of least resistance. And that's how you tell if your Ethernet cord is grounded or not. So and that's not working. If I touch the Ethernet cord, it's not changing any, because I do have my system grounded through the charging cord. So these are principles for daytime mitigation that are very, very important, that once you understand the principles, you can apply them universally when taking readings sitting in your office chair. Either wear shoes or take your feet off the ground. And this is also what happens if you have a grounding pad. Let's say you're using something like this with an alligator clip on it with a grounding cord. If I was to put my feet on this and it was grounded, my body voltage would go to 0. But the voltage that I'm sitting in would remain exactly the same. If you're laying in bed and you've got 2,000, 3,000 millivolts coming in from the wires in the walls, the floor, the ceiling, the clock plugged in, the lamp that's plugged in, and you put your feet on a grounding pad, your body voltage is going to go to 0 for the very reason I just showed you, because you've given the field a path of least resistance to ground. The meter is going to go down maybe to 0, but you're still laying in 2,000 millivolts. All that's happened with grounding is you've made yourself part of the circuit. And once you make grounding outside, making yourself part of nature's circuit. So your DC voltage, our body is very electronic, but it runs on DC voltage. Nature runs on DC voltage. So when you're outside, barefoot on the ground, walking on the beach, hugging a redwood tree or whatever your choice of grounding happens to be, you are connecting to the Earth's electric field. And that's DC voltage to DC voltage. That's extremely healthy. It's very, very anti-inflammatory, and one of the most healthiest things that you can do. Grounding makes you part of the circuit. When you ground inside, you are connecting to an AC field, an AC circuit. Your house ground probably has some AC voltage on it, some AC field attached to it. You are in an AC field. Like now, I'm in an AC field. So if I've put my feet on a grounding pad, rather than just being in the field, now that field that my body is acting as an antenna for is now flowing through me to ground. So I've now made myself part of the circuit. So my exposure by grounding inside, if I'm in an AC field, my exposure to EMF has actually increased, even though the reading says 0, because the field that I'm in is now flowing through me continuously to ground. Grounding outside is wonderful. It's one of the healthiest things you can do. Grounding inside, not so much. So what you want to do is, what I've done is ground the system. I've ground my Ethernet and my computer with the grounding cord, because I'm using a grounded power cord. And in Apple's case, their wiring just happens to work and do that. It's not, I'm sure it's not the reason they intended to do it, but it just so happens that we're fortunate in that that's the effect. So again, these are all principles that you need to understand. And the grounding thing is very controversial. There are lots of people selling grounding sheets and grounding pillows and grounding pads that you put your feet on when you sit in your office chair or you sit on. It upsets some people when I say that is actually increasing your EMF exposure, because for the reasons and the principles I've just explained to you. So what we're wanting to do is create for ourselves the healthiest possible environment, which is removing the source of the field. And when you ground the devices, they're no longer putting out an electric field that you're sitting in to be induced into your body in the first place. So turning something off with the EMFSafe switch, killing the circuits in the bedroom, running through the walls, the floors, the ceilings, removing the source. There's no electric field. There's no DE, which is part of the electric field. There's no magnetic field coming off of those circuits anymore, if there was any there in the first place. And there's no RF coming from the flat screen TV on the wall or any other device that might be a smart device that's plugged in to that circuit. So that is the most efficient and most effective way of reducing EMF in your sleep space, is by turning off the circuit. And what you can't turn off, if you're in an apartment and it's got old wiring, doesn't have metal clad wiring, and you're getting E fields coming in from your neighbors. You got circuits running through the wall that might belong to your neighbor who's on the other side of the wall. That's where we do get into shielding. And you can put up something like this, and then you must have a alligator clip on the corner of that. So this is going to absorb the electric field. It's going to block any RF coming in through the wall from next door. And then the grounding cord gives the electric field that this is absorbing a path of least resistance to ground. So again, this is protecting you laying in your bed. And that's the principle that we want to do. You can also use metal mesh screens like this. If you have a Wi-Fi router, and if I put this between me and the Wi-Fi router, this is going to block the signal coming off the Wi-Fi router. And some people in this office situation, they have to have it on. It can't be turned off. So by putting this between me and the Wi-Fi router, if it's like 3 feet, 4 feet from me on my desk or somewhere else, this will reduce the RF signal coming off of that by over 90%. So it's still there, you're still getting something, but it's 90% less than what it would otherwise have been. And again, under the bed, behind the headboard, this is what you can put behind the smart meter. If you've got a smart meter on your wall, figure out exactly where it is and put something up, put a poster up or a picture or some artwork, put this behind it, make sure it's grounded, and that'll block any electric field and any RF coming into the house from the smart meter. And that can be, you can measure that with your body voltage kit, how much field is coming in. And then you put this up and you'll see that it's significantly reduced, and you know that what you've done. And if you don't ground it, you'll notice you might actually increase the electric field. But as soon as you ground it, you'll notice the electric field drops. So this is a way to find fields and to make sure that what you've done has been effective and you're working efficiently. So this helps you gives you the information that you need to make informed decisions with your EMF mitigation. So now, again, a very controversial thing, because lots of people sell these covers, which is basically a material like this that's wrapped around the smart meter and it's put on the outside. Well, that's protecting your neighbor, because that's stopping the RF signal from the smart meter from going out. But if you don't put something on the inside wall to protect it from coming in, you might actually have increased your RF signal by putting the shield on the smart meter on the outside. You're protecting your neighbors. And if you have a smart meter on a building that's facing your house, then you definitely want to shield what's coming towards you. But this needs to be between you and the source. So putting this on the inside wall, stopping the signal from coming in the first place, is actually the way to protect yourself from a smart meter if your power company won't remove it. Sometimes in some places it's not an option, or it's going to take them a month or two to get to you. This is what you do in the meantime. So I'm probably generating a lot of questions, so I think I've covered the basics here for the people that are new to the body voltage kit. So one I'm using has the copper handle. Most of the ones out there have the aluminum handle. They work exactly the same. So if you have an aluminum handle, don't worry about it. They work exactly the same. Most of them do. Occasionally we use copper. Depends upon the material we have available to us. So that's one reason for the differences there. So and some of the circuit testers aren't blue, they're different color. It's just, again, depends upon our supplier and what we can get in on those things. Okay, well, I'm going to pause here for a moment. Been talking long enough, giving you a lot of things to talk about. Open it up for the first round of questions. Anybody got a question here? Don't be shy.
Hi, Anthony, it's Heather. I have a question.
Yes.
So does it matter, when you were giving the example earlier, well, does it matter to which outlet you have the grounding cord connected when you were talking about the issues around your computer, etc.?
No, you can actually, as long as you've tested the circuit, you've got the two orange lights, you've got a good ground, because some older houses that there is no ground, and this will indicate it. The little scale here tells you exactly what's going on. Then you have to find an outlet with a ground. Now, if you can't find one, or it's too far away because and you only bought the you only got the 12-foot cord that comes with the body voltage kit, and you didn't buy the 25 or the 50-foot cord, which is why we sell them, you can use any extension cord. If you've got a 20-foot or a 50-foot or 100-foot orange extension cord, you can find an outlet anywhere in the house, and normally there's almost certainly one in the kitchen. But if that's sort of like 20-30 feet to the bedroom, just plug in a regular extension cord, and then plug the making sure you got a good thing, plug this in the ground on the extension cord, and then plug your BVK into this, and then you can actually make the connection outside with an extension cord. Obviously, you've got the ground pin on the end of the extension cord. You'd have to get an alligator clip or something and then make a rod connection. All the new BVKs do actually, I don't have one here, do actually have the 9-inch grounding spike. So you could plug that in and then make a connection between the pin on the extension cord with the grounding stake. Just wrap a wire around it or something. So you should have an extra alligator clip on that, so you can actually, so this is your extension cord.
Okay.
You can, this, if you push hard, will go onto that, and then you clip this onto the screwdriver or the nail or the grounding spike that we now supply with the body voltage kit. So you clip this on the grounding spike, and then inside the house you plug this into the other end of not the plug end, obviously the socket end of the extension cord, and then you can use your body voltage kit in a house that has no ground. So that's the way you do that. So
I got most of that. I think I'm gonna have to go back and listen to it. I think I just got my kit recently, and I think I got something, it's in the house now, that's a long silver rod. Is that what you were talking about? That you would,
yeah, that's for
ground.
ground, for people who want to ground outside or have to ground outside because they are in an old house that hasn't been rewired yet and it has no ground.
Okay,
And
so I have a 1930s house. Many of the outlets are grounded. I have one that, of course, is right next to where I sit most of the time in the living room that is not grounded. So to test that outlet, I
okay,
would
let me jump in there.
yeah.
You're
Okay,
not
please.
testing. You're not when you're doing the body voltage reading. You're not testing the outlet. People think they have to go around and test every single outlet. I've had a few phone calls about that. You are not testing the outlet. You are just using the ground on the outlet as a path for the grounding cord to take the field away. So you can ground outside, you can ground to any other outlet in the house because you're not actually testing that outlet. You're testing the amount of field that
Yeah,
you are in, standing in that position, sitting
correct.
in that position, laying in the bed.
Yeah, that I understand that
Okay.
concept. But I still want to test just to know whether or not that outlet is safe so that if and when I have an electrician come to my house or that correct.
Yes,
I would use that.
when you
That's what I would use. Correct. So I would do
when you
that
test that
first.
outlet, if there's all you're doing is making sure that outlet is safe.
Correct.
If
But
the only thing wrong with that outlet is there's no ground, it's still a safe outlet. It just can't be used to ground because the ground wire is not connected to the ground in the
okay.
socket. So
That
it's
makes
still a
sense.
safe outlet. You still got a positive and negative. You can still plug your lamp into it. Now, if the positive and the negative were reversed, or sometimes you'll see, what are the various options here? Open ground, which is just one orange in the middle.
Mhm.
Open neutral, which would be very, very bad because you've now got a power, but there's no neutral going back. That's unsafe, and you want the electrician to fix that. An open hot, it just means the hot wires got disconnected somehow in some way. The outlet wouldn't work. And then if you've got a red and an orange, the outside orange, that's the hot and ground reversed. That's a very, very dangerous position because then if you ground to the ground, you're actually connecting yourself directly to the hot. That is the worst possible situation. And that's the number one reason why we test the circuit, because if that's the case and you do this, you just got electrocuted. So that's why we test.
Exactly. But that's what I wanted to clarify. I want to know information about that outlet so I know how to proceed outside of measuring my own body voltage. But once I do that with the ungrounded outlet and I get that information to set aside possibly for later with an electrician, I can plug in the grounding cord on the BVK, the body voltage meter on another outlet in the room, as long as it stretches close to within 6 to 8 feet of that original non-grounded outlet that I want to test. No. That's where I'm not understanding. Okay.
So if the outlet next to the bed or next to your chair, there's no ground. You can't use the ground. The outlet's fine. It's, if this tells you it's fine, it's just that there's no ground. So you can run your grounding cord. There might be another outlet that this will reach. So you just plug into that.
That's what I mean. Yeah. I would plug it into the one across the room.
Yeah, but you can use a 50-foot cord into another room or out the window using the grounding spike. The proximity to the how long a grounding cord you use doesn't matter at all, because where you're plugged in has absolutely nothing to do with the reading other than you're using the ground. What you are reading is what's happening here in your chair, laying on your bed, standing in your kitchen. And, if this is a 50-foot, a 5-foot cord or a 50-foot cord or a 500-foot cord, it doesn't make any difference.
Right. But my question is, if I want to test the spot where I sit most of the time in my living room, and the outlet next to that is ungrounded, so I can't plug in the the meter with the grounding cord into that, I can plug that white grounding cord into another grounded outlet in the room and still hold it on the couch to find out what voltage, or I'm sorry if I don't have the right word, my body is receiving right now, because it's
Absolutely.
grounded, it's going to give me an accurate reading as long as
Yeah.
I'm wearing shoes,
Yeah,
right?
this only works, the body voltage kit only works if you have the grounding cord plugged in. But where you plug that in doesn't matter. It can be anywhere in the house. It can be your next door neighbor's house. It doesn't matter.
Okay, great. Thank you very much. That was very helpful.
You're very welcome. It's a good question. There is a lot of confusion over that. And people think, oh, well, I'm in my bedroom and I've turned that outlet off at the breaker. Can I still use the ground cord in that circuit that I've just turned off? Yes, you can, because when you flip the breaker, you're only turning off the power. You're disconnecting the power line on that circuit. The neutral's still in place and the ground is still in place. When we connect up the EMFSafe switch, there's two versions of it, the power only disconnect, the PO, or the NP, which is the neutral and power disconnect. Even then, when you hit the button and you kill that circuit in your bedroom or any other room you happen to disconnect the circuit using the cutoff switch, we are not touching the ground. So if you had a good ground to begin with, you still have a ground and the body voltage meter will still work in that outlet. Even though the outlet's dead, if the ground was good beforehand, we have not touched the ground. We are not allowed to touch the ground by law, by code. You have to leave the ground connected. And we can only disconnect the neutral with the power if it's done simultaneously, so that the neutral and the power have to go to the same relay. So when you fire the relay and it disconnects the circuit, the neutral and the power are being disconnected simultaneously. And that's by NEC code. We are a UL lab, and we were actually inspected. We had a surprise inspection a couple of days ago. The guy just showed up and he make sure that everything that we're doing is correct and done to code. And we get like 3 or 4 inspections a year. They just show up and, what are you doing? Let's show us the latest thing you made. And okay, yeah, you're building it to code. And it's a very, very expensive to be UL listed. Let me tell you that it's not cheap. And thank you. Good questions, Heather. And I've had several phone calls with people over the last few weeks, actually asking similar questions. So as hard as I try to explain everything on the videos and on calls like this, these are all new concepts to a lot of people. And it's like, okay, I hear the words, but I'm not sure what they mean. So
this is Lori.
Hi, Lori.
Hi, can we test in our car?
Well, yes, but you'd have to use the that's actually one of the reasons why you can actually have the car running in the driveway. You obviously can't test in the car while you're driving down the road because there's no way you can ground, but you can use your grounding cord and the grounding spike. And if your driveway's got a piece of grass right next to it, you can use the grounding spike with the grounding cord and sit in your car and take a body voltage reading. Yes, you can test in your car. But obviously the whole point of testing in your car would be the alternator. Now the alternator is going to be running and be putting out an electric and a magnetic field. This is not testing the magnetic field, but it would show you if with the car turned off, take a reading, turn the car off, rev up the engine. Now the alternator is spinning. And you can see the difference and see how much electric field you're getting from the alternator. Now, as far as an EV, obviously anything coming off the motors have to be turning. So you'd have to have a very long cord and run up and down the street with a cord behind you. But the biggest problem with gasoline cars and electric cars, believe it or not, isn't so much the electric field, it's the magnetic field coming off the alternator and off the motors, depending upon which company and which version of which car you happen to have. But the biggest problem with all modern cars, be it the electric or gasoline, is the Wi-Fi and the Bluetooth. You've got I've got an older model car. It's a 2006 model. There's nothing smart about it. One of the reasons why I like it. We live in an area where the local cell tower is over half a mile away, and once I get off the property where I'm living, I take a RF reading. My phone's in the car on airplane mode or turned off, and my microwatts per meter square are 1 or below, which is the reading that you want to see, 1 or below microwatts. If I turn on my phone or take it off of airplane mode, I got to 20,000 microwatts. That's 20,000 times higher than what they recommend as being safe. Now, if you're driving a smart car that's got Wi-Fi and Bluetooth, you've probably got the equivalent of 2, 3, 4 smartphones built into the physical structure of the car to create the satellite link to do all the things that your smart car is doing. So your RF reading from the Wi-Fi and the Bluetooth plus your phone, so you can turn your phone off. But if you haven't disconnected the Wi-Fi and the Bluetooth in that car, you are being radiated inside that metal box. Plus, you've got the magnetic field reading from the alternator if it's a gas car, and the electric motors if it's an EV. You need to buy an old. If you're worried about it, if you spend an hour, 2 hours, 3 hours in your car a day, commuting and things like that, get an old car that's not smart, or find out if, and some models you can disconnect the Wi-Fi and Bluetooth, but most of them you can't, or the fuse, when you find out which fuse it is, also has something important like the indicators. So if you pull the fuse, you now don't have any indicators. So it's not like they designed them that way or anything, but so yes, you can test your car sitting in the driveway, but that's about it. So
Thank you. Fascinating. Something to think about.
Yes, it is. Yes, it is. Kind of scary in a way, what we're doing to ourselves with our modern, and I always, when I write it, put smart in quotes, because it's not so smart. So any other questions?
Hi, Anthony. It's
Yeah.
Suzanne.
Hi, Suzanne.
Like Heather, I live in a probably same circa building, really funky wiring. I've discovered that my the few little sockets that are in my bedroom are the old-fashioned type that don't have the 3-prong. And
Okay.
I did plug in, I think it's a green wave meter to measure that. And, you know, one of them was over 1,000 exactly. So I know I've got tons of issues. And when I use my BVK to measure, you know, I've got 3 different breaker switches just in the bedroom. All the rooms are double split, and it's just a complicated situation, like I'm sure other people have, but I won't go into the details of that.
No,
What
we see that all the time. Yeah, so go ahead.
What I wanted to ask is, the bedroom's one thing, and I've been working on that for over a year and getting all kinds of reads, Anthony. And but I've been also really working on the office area. And one thing my landlord reminded me of is that because I live in a really urban area, with all kinds of stuff everywhere, around me, above me, next to me. But what she reminded me of, which I totally forgot, because I think this is one thing that's throwing off my body voltage kit in the office area, or rather giving me really high reads, is there's a grocery store about a block away, and they put in some charging stations for the electric cars, and they didn't have enough power on that block, and they came down our block in front of our building. And I'm on the ground floor, right on the, you know, kind of facing the street. And I was so glad that she reminded me of that. Now, could something just outside my window where I'm measuring my office area with the kit, could that give me some really high numbers that, because I just can't seem to make impact in that area.
Okay, yeah, you've got a whole bunch of different things there, but some really important stuff to go over and cover that will not only hopefully help you, but help other people listening. So when you say outside your window, how far away is it?
It's pretty close. I would say sidewalk's right outside my window, and then, you know, the street is right there, and that's where because they tore up our sidewalk right in front of our building to put part of this in.
So how many feet?
Maybe it's definitely less than 50.
But it's about 50 feet.
Yeah, yeah.
Okay. So couple of things there. I have no idea because that's all new technology and I don't know what they did or how they did it. But
Yeah,
if
sure.
if what they did is 50 feet away, you're not getting anything from that directly. Now, the charging station that close to you could definitely be affecting your dirty electricity, but we need to separate dirty electricity from the electric field it rides on. This does not measure dirty electricity. You do need the EMI meter, and you know, remember the green wave, the Stetson meters, Stetson meters are only measuring a very narrow range of dirty electricity. They are specifically designed to measure the frequencies that their plug-in filters are designed to filter out.
Right.
They don't measure the fields over here. They don't measure the fields over here. So when you use professional equipment and you're measuring the full spectrum, the green wave plug-in filters and the Graham-Stetzer plug-in filters, you know, they're not operating as well as this meter would indicate, because this isn't measuring the whole field. So let me just say that, which is why we sell the whole house DE filter, goes on your panel or next to your panel. That is filtering all the dirty electricity, not all the dirty electricity, 80–90% of the dirty electricity coming into your home from being on the circuits in your house, and it's filtering the dirty electricity on every circuit in your house 24/7. And when measured with professional equipment with an oscilloscope, where we're actually measuring the full range, all the frequencies, we are seeing about a 70–80% reduction with our whole house DE filter, which is an optional extra for the EMFSafe cutoff switch. So the plugins are filtering out some. I mean, they are doing something, but they can also create magnetic fields, which ours being on the panel doesn't. So you've got the dirty electricity reading, and 1,000 obviously is high. And so that would indicate that if you were to turn off all the circuits in your house, except for one, and take a DE reading and see what it was. If it's still 1,000, then it's either on that one circuit, the source of the DE is either on that circuit or it's coming in from the outside. So you now turn off that circuit, and then you need to turn on another circuit, the one below it, and then plug this into the outlet that's on that circuit and see if you still have 1,000. And if you do, then by process of elimination, that 1,000 is coming in from the outside. The only way you can reduce the DE coming in, riding on the electricity coming into your house from the grid, is to put a filter on your panel, which is what the EMFSafe switch with the PQ filter does. That'll filter that and reduce the amount of DE coming into your home. And could that Tesla charging station be contributing to the DE? Yes, there's a very, very good chance of that. Now, the electric field reading that you're picking up on, if you've turned off those 3 circuits, it should be significantly reduced. And by turning off those circuits, obviously the reading during the day in your office, and well, where do I plug in my computer? Well, you run an extension cord in from another outlet. So the field from the wire in the wall that's running right behind you or right down by your feet, if the desk is facing the wall, if that circuit's off, it's not radiating out into the space all the time. And if you've got old wiring with no ground you can't ground any of your devices to that outlet because there is no ground to ground to, as we just covered earlier. But if you've got knob and tube wiring, then if you were to measure the magnetic field, it'd probably be off the charts as well, because the knob and tube, the wires are separated. So in Romex, the magnetic field going this way is neutralized by the magnetic field going that way. So you don't get, with a correctly wired house using Romex, you shouldn't get a magnetic field. You still get electric field, but you don't get a magnetic field. Now with Romex, with knob and tube in these old houses, the positive and the negative are separated, which means now you're getting the magnetic field off of the positive going out and the neutral coming back, and that's radiating out. So by turning off those circuits, getting an extension cord from the kitchen or somewhere else in the house and running it into that room, and then plugging a power outlet that is grounded, and plug everything in as far away from you as possible, away from your feet, not down by your feet. And then that gives you a ground that you can do what I did, use, you're charging your computer, your laptop with a grounded cord. That is the way to mitigate an office. We recommend that all the time. So you still need to turn off that room, which sounds counterintuitive. You turn off that room, and any wires running underneath the floor, going somewhere else in the house, run in an extension cord, keep that as far away from you as possible, and then plug all your devices in. Now you've got a ground. So if you've got a tower computer, they almost always have a 3-prong plug on them. There's a ground. Normally you don't get an electric field off of a tower computer, but you do off of laptops, because they don't have the ground. They just got the two pins,
right?
And they're not grounded. And that's when if you're using one of those chargers, you pick up your phone. In addition to the Wi-Fi, the Bluetooth, and the cellular signal coming into you, you now have 10,000 millivolts. And if it's an iPad or a laptop computer and you're touching it, your body voltage is going up to 40,000. So either don't use it while it's charging, or make sure you use, like I am, use a grounded connection. And when you do talk on your phone, let me cover that very quickly, because there are devices that you can get. This is available on our website from Shield Your Body. And this is just a plate. It's covered with kind of leather. I don't know if it's actual leather, but it looks like leather, feels like leather. Got a place for credit cards or business cards. So if I'm talking on the phone on speaker, I'm not doing this.
Right.
I put this between me and the phone, and now I can talk on the phone. I can be heard, and I can hear the person on the other end, but I'm shielded from the phone signal coming into my head and into my body while I'm doing this. But the back is open. I'm not using a Faraday thing, which would force the phone to up its power. It's going to ping the tower. If it doesn't get a signal, it doubles the signal. If it doesn't get a signal back, I hear you from the tower, it ramps up. It can be up 10 times, 50 times, 100 times power looking for a signal. So if you use a Faraday phone case, you're now forcing the phone to work at a much, much higher power. If I leave the back open, my phone is operating at the lowest power possible to make the connection. And I am protected from that because this broadcasts 360 degrees. So now it's broadcasting that way, not this way towards me. So I can talk on the phone, and it's not perfect by any means. I'm still getting radiated, but it's 90% less than if I just did that.
Right. And this also explains why my battery goes low so fast.
Yep.
Despite how often I'm
point.
charging it. I mean, Anthony, my brain capacity is much slower than normal. I think there's other people from Sinclair and Michael's protocol in here, cohort, so they might be able to agree on this. But we're making these pedestrian moves to increase our situation, improve our situation, and there's so many factors, and they're so individual based on people's circumstances and everything. And so
Well,
So
the
many of these-
principle, you're right. The principles are solid. And once you understand the principles, which is why I spent so much time on them, you can
Yes.
apply them universally. But unfortunately for you guys coming into this, and for people like myself who's been doing this for multiple years, there is so much misinformation out there. That's
Yeah.
actually counterproductive. It actually, there are devices that actually increase your exposure.
Yeah, I think so. And also that I think a lot of us are operating from, a not particularly well place. And so
Of
our
course,
concentration and ability to absorb the information. I mean, I've been at this a little while now and I still feel like I'm new,
yeah,
so
I don't have mold where I live, and I'm not sensitive to it per se, but I did have an experience once when I was on one of those, where you recycle cans. You go, they have these places where you go and you feed your
Sure.
cans to it. I did that, and so I was there for like 5-10 minutes. We had a bag of cans that we were recycling. All of a sudden, my vision started to shut down. My brain went numb. I couldn't think.
wow.
My phone rang, and I answered the phone. I knew it was my brother. I couldn't think of his name.
Wow, what an
My
immediate
brain shut down so much. I've had maybe one other incident where something like that started to happen, and I immediately left the place that I was in. So I have experienced mold toxicity, and I know what it can do to your body. And to have that over any length of time, the debilitating effect it has on you. But to be talking to my own brother, and I'm thinking, I know this is my brother. I can't remember his name. And I'm not even sure I can remember my own name. It was that scary. It was
There you were, you're a well person experiencing that, right?
I was a well person experiencing
Yeah.
that. And it was, and I'm actually very glad I had the experience, because it now allows me to understand, working with Michael and Sinclair's, all of you people, just what you are experiencing on a daily basis, and people who've lived in a home, and some of the symptoms. But that was a scary experience. So I do understand and appreciate. And so what we want to do, and remember, the higher your level, EMF makes mold grow 10 times faster.
Right.
So one of the best ways to mitigate, along with all of the other procedures that you're doing to get the mold out of your house, is reducing the EMF, as well as all of the stuff you're doing personally to get it out of your body. So yeah.
I very much appreciate that. And thanks for sharing that
You're very
experience.
welcome.
It
Yeah.
puts it in perspective for the rest of us that have been with it for so long. So
Yeah.
thank you, Anthony.
Yeah, you're welcome. So anybody else? We're coming up on an hour. I've allocated 2, but I'd really rather not. In fact, what I'm going to do is I'm just going to say thank you, everybody. I'm going to check off the recording, because I'd really like to keep this to an hour. It just makes life a lot easier to upload it and things like that. We've covered a lot. So thank you, everybody. Those that are listening to the recording, if you have any questions, feel free to call. There's videos on the measure page, all the information about the EMFSafe cutoff switch and the PQ filters on the website. But if you have any questions, don't hesitate to call liveemfsafe.com, and the phone number is 541-944-3630. And thank you, everybody, very much.
Thank you for making yourself so available, Anthony.
You're very welcome.